Hey everyone, it's Mr. Irwin. I hope you're doing well. In today's lesson, we are going to take what we learned in our previous lessons, the greatest common factor and the least common multiple, and use those tools to solve word problems. So if you look at your screen, we have our first word problem. It says, Mrs. Walker has a piece of red ribbon 18 inches long and a piece of blue ribbon 24 inches long. She wants to cut each piece of ribbon into smaller strips so that all the strips will have the same length. Without wasting any ribbon, what would be the longest possible length of each strip of ribbon? Now, when we look at the question to this problem, what would be the longest possible length of each strip of ribbon? That gives us a clue as to what type of problem it is. The word longest insinuates that we are dealing with the greatest of something. In this case, the greatest common factor. So our task is to find the greatest common factor of the values in this problem. Mrs. Walker, she has red ribbon that is 18 inches long. So let's find the factors of 18. So starting with the red ribbon. Well, if I'm finding factors of 18, I know every factor starts with 1, and 1 times 18 gives us 18. Working down the number line, we're next going to test divisibility by 2. 18 is even, so it will divide evenly by 2, and its factor partner, 2 times 9 is 18. On to 3. Looking at 18, if you remember your divisibility rules, sum the digits. 1 plus 8 is 9. 9 is a multiple of 3, therefore 3 is a factor of 18. We need a partner for 3. 3 times 6 gives us 18. Testing divisibility by 4. 4 will not go evenly into 18. Our next value to test is 5. 18 does not end in 0 or 5, so 5 is not true. And then the next value on the number line is 6, which is a repeat, which tells us that we have all of the factors for the 18-inch red ribbon. The next piece of ribbon we are dealing with is a blue ribbon that is 24 inches long. So let's factor the blue ribbon. It is 24 inches long. Our first factor is always 1. 1 times what gives us 24? 1 and 24. Next, 24 is even, so it is divisible by 2. 2 times 12. 3, 24, 2 plus 4 is 6. 6 is a multiple of 3. Therefore, 24 is divisible by 3. 3 times 8 gives us 24. Next, 4. Counting by 4s, you will eventually say 24. So 4 is a factor of 24, and its partner is 6, because 4 times 6 is 24. Testing divisibility by 5. 24 does not end in 0 or 5, so 5 will not work, and then 6 is our repeat. Now that we have all the factors listed for both the red and the blue ribbon, we want to find the longest possible length, which would be the greatest common factor. So the largest value that appears in both is 6. So the longest possible length she could cut each ribbon would be 6 inches. All right, let's do another example together. Again, you should be completing this work on a sheet of paper with me. This example says, Barbara's mom owns a bakery. She sells muffins in packs of 4 and donuts in packs of 6. What is the least number of packs of each you must buy in order to have an equal number of muffins and donuts? So looking at our question, what is the least? That's our key word. So this problem, we are doing least, common, multiple. Starting with the muffins. We know muffins come in packs of 4. So if I buy 1 package of muffins, that would give me 4 muffins. If I get 2 packages, I would get 8 muffins. 3 packages, 3 times 4 would give me 12 muffins. 4 packages would be 16. 5 packages would be 20. On to the donuts next. We know donuts come in packs of 6. So working out the donuts, we're looking at multiples of 6. 1 package of donuts would be 6 donuts. 2 packages would be 12. 3 packages, 3 times 6 is 18. 4 packages would give us 24 donuts. Remember, we're looking for the least common multiple. What is the smallest multiple that appears in both series? We have 12. Now, that means the least common multiple is I would have 12 muffins and 12 donuts. But the question does not want to know the least number of donuts. It wants to know the least number of packs. So how many packages of muffins would I need to buy to get 12 muffins? Well, I would need 1, 2, 3. So I would need 3 packages of muffins. And then the donuts, to get 12 donuts, I would need 1, 2 packages of donuts. So the solution to this problem, what is the least number of packs of each you must buy in order to have an equal number of muffins and donuts? You would need 3 packages of muffins and 2 packages of donuts. That way you had 12 of each. All right, here's a word problem for you to try on your own. There are 32 forwards and 80 guards in Leo's basketball league. Leo must include all players on a team and wants each team to have the same number of forwards and the same number of guards. What is the greatest number of teams Leo can create? Go ahead and pause this video, work this problem out on your own. Once you've completed it, begin playing the video again and check your work to see how you did. Hopefully you've given yourself enough time to complete this problem on your own. Let's work it out together, starting with the question, what is the greatest? So that is a clue for us saying, hey, we need to find the greatest common factor. Starting with the forwards, there are 32 of them. So we need to factor 32. 1 and 32. 32 is even, so it is divisible by 2. 2 times 16 gives us 32. 3 plus 2 is 5. That is not a multiple of 3. Therefore, 3 is not a factor of 32. If you count by 4s, you will eventually say 32. It's 4 times 8. It is not divisible by 5, 6, or 7, and then 8's my repeat. So there are all my options for the forwards. Next, we have the guards. There are 80 of them. So for the guards, we want to factor 80. 1 and 80 is our starting point. 80 is an even value. So 2 will divide evenly into it, 2 and 40. When you sum the digits of 80, 8 plus 0 is 8. That is not a multiple of 3, so 3 is not a factor. 4 will work, though. 4 and 20 gives us 80. 80 ends in a 0, so it is divisible by 5. 5 times 16 gives us 80. 2 is true, but 3 was not. That means 6 cannot be true. 7 will not go into 80, and then 8 does go into 80. It goes in 10 times. 9's not an option, and 10's my repeat. So there are all my factors of 80. We're looking for the greatest common factor. What is the largest value that appears in both? I see 8 as a common factor. I see 4 as a common factor. 2 is a common factor, but the greatest is 16. So what is the greatest number of teams Leo can create? He could create 16 teams. Please complete the independent practice on the greatest common factor and least common multiple word problems. Take a picture of your work and upload that image file for submission. I'll see you guys next time.